Hello, I'm Sienna Bowes, and welcome to my channel, Learningbuildslife. Today, we are going to talk about the study of an element from the analysis of its electronic configuration, or in short terms, EC. I am going to present before you fluorine and chlorine today. Let us start with fluorine. Fluorine. F. First, atomic number. Atomic number is 9. Now, electronic configuration, or EC. EC is 27Kl, which means there are 2 electrons in the K shell and 7 in the L shell. Therefore, number of valence electrons is number of valence electrons, which means the electrons in the outermost shell, which in this case is the L shell, is 7. There are 7 electrons in the L shell. Now, period number. Therefore, period number is 2, since there are 2 shells, K and L. Group number. Group number is 10 plus number of valence electrons, since the rule suggests if number of valence electrons is 3 or more than 3, then we have to add 10 to it to determine the group number. Here in this case, 10 plus 7 gives 17 as the group number. Now, valency. Valency is 8 minus the number of valence electrons, since the rule suggests if number of valence electrons is 5 or more than 5, we have to subtract that number of valence electrons from 8 to get the valency. In this case, there are 7 valence electrons. 8 minus 7 gives 1 as the valency of fluorine. 1. Now, fluorine's identity. Fluorine has 7 valence electrons, but the property says if an atom of an element has 1, 2, or 3 number of valence electrons, it is a metal. But fluorine does not satisfy this condition, so it is a nonmetal. Fluorine is a non-metal. Now, neon is the nearest inert gas to fluorine. Neon, Ne. Neon is the nearest inert gas with a stable electronic configuration of 2,8. To attain the stable electronic configuration of 2,8, fluorine gains 1 electron. On gaining, it has 9 protons in the nucleus, but 10 electrons in the 2 shells altogether, creating a negative charge on the fluorine atom, forming an F- anion. An anion is a negatively charged atom. Now you can have a look at all the derivations we got from the electronic configuration of fluorine. Here we go. Now we will talk about chlorine. Now, chlorine. Chlorine, Cl. First atomic number. Atomic number is 17. Now, electronic configuration, or EC. EC is 2, 8, 7, K, L, M. That means there are 2 electrons in the K shell, 8 in the L shell, and 7 in the M shell. Therefore, number of valence electrons is number of valence electrons, which means number of electrons in the outermost shell, which in this case is the M shell, is 7. Therefore, period number. Period number is 3, since there are 3 shells, K, L, and M. Group number. Group number is 10 plus the number of valence electrons. Recall the rule we used in the analysis of fluorine. It is 17. Now, valency. Valency is 8 minus the number of valence electrons. Again, recall the rule we used in the analysis of fluorine's valency. 8 minus 7 gives chlorine the valency of 1. Now, chlorine's identity. Chlorine has 7 valence electrons, but the rule says if an atom of an element has 1, 2, or 3 number of valence electrons, it is a metal. But chlorine, again, does not satisfy this condition, so it is a nonmetal. Chlorine is a nonmetal. Now, argon, Ar, is the nearest inert gas to chlorine with a stable electronic configuration of 288. To attain the stable electronic configuration, chlorine gains 1 electron. To attain 288, the stable electronic configuration of argon, the nearest inert gas to it. On gaining 1 electron, it has 17 protons in the nucleus, but 18 electrons in the 3 shells altogether, creating a negative charge on chlorine, forming a Cl- anion. Anion is again a negatively charged atom. Now you may have a look at the analysis of chlorine's EC. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.